Hello, dear colleagues. Let me introduce my cute teammates Leonid Litovchenko, Ekaterina Vorobyova, Mikhail Vasilkovsky, and Yegor Konyagin. This is our deep learning final project. It is devoted to unsupervised learning of novel view synthesis of faces. First of all, I'll tell you about the problem statement, then theory review and experiment setups, and after that I'll tell you about our results. So, let's start. Given a target face and a driver face, face reenactment aims to synthesize a reenacted face which is animated by the movement of a driver, while preserving the identity of the target. We have studied novel approaches in the field and decided to focus on the still poorly solved at this moment subtask, reenact a face, which is rotated on a large angle. Even state-of-the-art approaches, such as first-order motion model or simply FOM for images, they fail to produce a convincing result when the angle of rotation is high enough. For now, manipulating head poses in particular form as single images is an open-end generation task. The main reason we see is the ill-posed nature of lacking paired training data. Most of the data sets are either not diverse enough in persons or they have only approximate angle labeling. And yet, the task of learning and understanding 3D representations from 2D views is solved by human beings. It motivates our team to explore entirely unsupervised approaches to learn feature representations and which are appropriate for novel view synthesis. So, three approaches were thoroughly studied and multiple experiments were set up. The first is hologun and inside face model. The second one is hologun and latent space optimization. And the third one is stylegun of version 2 plus hologun like style encoder. I will explain about each experiment thoroughly, and we compared our results on validation images with state-of-the-art FOM results. Let me first explain the idea of hologun. Hologun is a generative adversarial network for the task of the unsupervised learning of 3D representations from natural images. Most generative models rely on 2D kernels to generate images and make few assumptions about 3D world. These models, therefore, tend to create blurry images or artifacts in tasks that require strong 3D understanding, such as novel view synthesis. Hologun instead learns a 3D representation of the world and to render this representation in a realistic manner. Unlike other generative models, Hologun provides explicit control over the pose of generated objects through rigid body transforms of the learned 3D features. It can be trained end-to-end from unlabeled 2D images only without requiring pose labels, 3D shapes, or multiple views of the same objects. Inside face architecture is a model used in face recognition task. The training took 31 hours for 100,000 iterations. The most important advantage of this approach is that it can produce coherent multi-view representation despite the angle of the initial photo. Model of such kind tuned to produce higher resolution images and could be used as a preconditioner to other models like FOM, which poorly digest initially deviated head poses. And now I will show our results. You can see the results here. It can be observed that this approach beats the FOM model when the angles for rotation are large.